Alright, today we're going to look at our last method of solving systems of equations. So we did graphing already. So remember, when you graph your two equations, you find the intersection points, and those will be your solutions to the system. Or we looked at where we have two separate equations. Something like that, where we just take...
Mr. Stevens, please have...
We would take the y equals for one and plug it into the y for the other, and that would give us a quadratic equation that we could then solve. So today's method is going to be similar to substitution. It's just going to be algebraic, but it tends to work a little bit quicker, and we call it elimination. And what happens is, if we line up our two equations where all of our same terms are lined up, the x's, the y's, the x squareds, and so on, we can actually add these things vertically. And if we can make it so that our y coordinates are opposite to each other, they actually cancel out. So we have 2x plus 1x equals 3x. The 3y and minus 3y cancel, give us 0. 15 plus 3 is 18. So we just get 3x equals 18, x equals 6. So it's a pretty quick, easy way to solve for x. And then all we'd have to do, just like before, plug that back into one of them. So let's do the second equation. So we'd have 6 minus 3y equals 3. Bring the 6 over, that gives you negative 3, so y equals 1. So that means in this case, 6, 1 would be our correct solution. So the steps for solving by elimination is, the key thing is to make sure they're lined up vertically so that everything's in the same spot. It doesn't matter what order you put them in, as long as they are the same for both equations. Then what we want to do is, usually we have to change one of the equations, or both sometimes, to get the y values being opposite to each other. So if you have a y, you want the other one to be negative y. If you have a 5y, make the other one negative 5y, and so on. So then we just add everything vertically and solve for x. Plug that x value in to solve for y afterwards. Okay, so let's try this one. So here we've got y equals 2x plus 5. So we can leave it in that form. And then we just got to change our second equation to be the same. So in the second one, if we bring the y over, that would give us y, oops, not negative y, just positive y. So we'd have positive y equals x minus 2. So you can see they're all lined up the same. So the only thing we got to do differently is we need them to be opposite. So if we times the entire second equation by negative 1, that would give us 2x plus 5 for our first equation, and then we'd have minus y would be negative x plus 2 for the second. Now we can add these up, so we get 0 equals x plus 7, and bring the 7 over, so we have x equals negative 7. And then plug that into one of our originals, so we'd have negative 7 minus 2, so that gives us negative 9. So negative 7 and negative 9 is our correct solution to this system. So let's try another one, and this time let's rearrange it slightly different. So let's bring the x value over. So we have minus 2x, we'll leave the y where it is, and let's leave the 4 where it is. So all I did in this case was just brought the 2x. Second equation is good the way it is. We can just line things up the way they are. And now you can see our y values are, one's positive, one's negative. That's good, but we need them to both be the same number. So if we times our top equation by 2, so that would give us minus 4x plus 2y equals 8. And now we can actually add those two up together. Okay, so we have 3x minus 4x would be minus 1x, the y's cancel, and we have 4, so x equals negative 4 will be our solution. And plug that back into one of the originals. Let's go with that y equals 1. So 2 times negative 4 plus 4 would give us negative 8 plus 4, which is negative 4. So negative 4 should be our solution to that system. So you can see it's a pretty quick method, and most people like it a little bit better than substitution, just because it is a little bit easier to do the math. Here's one that we have a quadratic and a linear. They still work the same way, so let's leave the quadratic the way it is. So let's rearrange our second equation. So if we put the 10 first, so that 10 lines up with the 0. We've got our 5x lining up with the x, and our y lines up there as well. So you can see it kind of worked out. Probably would have been better if we would have brought the 10 to the other side and the 5x and the y to the opposite side like that. So let's write it like that. So minus 10 minus 5x plus y. So now you can see our y's are opposites, but we need the second one to be double again. So let's times this whole thing by 2. So we would have had 20 and then negative 10x and 2y. So now when we add these up, we get negative 20 equals x squared minus 9x, and the y's cancel. So let's make it equal to 0. So that would be that. So now when we factor, we should get minus 5 and minus 4. So our two solutions are 5 and 4. So just like before, we need to still get our y values. So let's use our second equation. It looks a little bit easier. So let's plug that in. So we'd have 5 times 5 minus y equals 10. So that'd be 25 minus y equals 10. Let's bring the 10 over and the y over the other way. So we get 5 and 15 would be our first solution. And do the same thing with the 4. So 5 times 4 minus y equals 10. So we have 20 minus y equals 10. Bring the y over, the 10 over the other way. And 4, 10 would be our second solution. These questions that we're doing now are the exact same we did with substitution, and we are getting the exact same answer. So it really doesn't matter what method you pick. It'll work just as well for both. So here's our last one. You can see our y's are almost the same. We just got to make them both, the 2 and the 4 line up. So let's make it minus 4 equal to 0. So that works. And let's change our top ones to all be opposite signs, so timesing it by negative 1. Now we can add them up the way they are. So we have 3x squared plus 5x minus 2. And when we did this one the other day, we got 3x plus 1 and x minus 2, I think was the right answer. Oh, backwards again. So that should have been 3x minus 1 and x plus 2. So our solutions are 1/3 and negative 2. So plug those back into the originals, and we should get the exact same answer we got the other day, which was 1/3 and I forget what it was. I think it was 2 or something like that. So 1/3 squared is 9. 1/9 times 3 would be 1/3. Minus 1/3 cancels. So I think it was 1/3 and negative 2 is our one solution. And then our second one would be negative 2. And when we do that one, we got 4. So that's 12. Plus 2 would be 14. Minus 2 is 12. So negative 2, 12, I think was our second solution. And that's it. So elimination works well. Just make sure everything's lined up, cancel out your y's, and solve from there.